Okay, so good afternoon. We are going to continue the tutorial 10. Today this week is week 12. Okay, for the line integral. Okay, so this last week we have covered the line integral of scalar field, differential forms, okay, and vector field. Today we are going to cover the conservative vector field and Green's theorem. Then we finish the line integral, just left 2 weeks for space integral. So the conservative vector field, okay, the fourth subtopic in the line integral. Look at the question 1. This is a conservative vector field. Question 1 is this is a direct question where given the vector field F in 3 dimensions. Question A, show that F is conservative vector field. So normally, if this type of question, the vector F is normally 0 vector once F is conservative vector field. Because the question is positive, the sentence is like positive sentence, and then you can see find a potential function P such that F equal to del P. So the answer you have to show that the curl of F you can get 0 vector. And then use the potential function to evaluate the work done by the force field on a particle that moved from -2 to 0 to 101. So this is a guided questions. Solve the one. First step, find the curl of F. The curl of F del cross F. Del is a differential operator if the F is three dimensions. Then the del is a 3 dimension. Del xi. F component I is 3x squared plus y z exponent x1. Okay, component j for del is del y. Component j for vector F, this is x z exponent xy minus 4y. Okay, component k for del k is del z. And then the vector F is exponent xy minus 6 exponent 2z. Then you have to show that the curl of F, okay, here it will get 0 vector. So to get the curl of F is a vector. So to get the component I, you close or cross the component I here. Then you left determinant of 2 by 2 matrix. Takes the main diagonal, which is del y exponent xy minus 6 exponent 2z minus this one. We have this here minus this one. Minus del z with xz exponent xy minus 4y. Make sure you check it normally. next case for component I, j cos k is positive I. So we have basically delta y exponent xy minus 6 exponent 2z minus delta z x z exponent xy minus 4y. Okay, this at the component I. This is component I. Component j is negative because you cos k or close the component j, I cos k is negative j. So we close this one. So we have here okay, I cos k is negative j. So we have delta x, this one, exponent xy minus 6 exponent 2z minus delta z. So this is delta. So minus delta z, this one, 3x squared plus yz exponent x1. This is component j. Please double check delta x exponent xy minus 6 exponent 2z minus delta z 3x squared plus yz exponent xy. Okay, then erase this one. Lastly, for component k, you close it, then I cos j is positive k, so it's plus positive k. So delta x exponent z exponent xy minus 4y. Delta x z exponent xy minus 4y. And then minus, this is y, minus delta y 3x squared plus yz exponent xy, component k. You have to show that each component you get the answer is actually 0. Okay, now for component I, delta y exponent xy. Delta y exponent xy, you have x exponent xy. Okay, and delta y negative 6 exponent 2z, when the delta y z is constant, that's why this term, delta y negative 6 exponent 2z, you have 0. Okay, and then, so if negative minus delta z, okay, delta z xz exponent xy. Okay, this one you have the product of here. No need to use product rule because when you delta z x is constant, exponent xy also constant. That's why you delta z, okay, x z exponent xy, you have okay, exactly constant is this one. This is constant, this is constant. That's why you get the result exactly x exponent xy. Okay, and then delta z negative 4y is 0. That's why component I. X exponent xy minus x exponent xy, you get component I is 0. Okay, and then component j, okay, delta x exponent xy, you have y exponent xy. Delta x, okay, negative 6 exponent 2z, you have 0 because when delta x, z is constant. So it minus, okay, delta z 3x squared you have 0. Okay, delta z y z exponent xy. Okay, let's see. Okay, when your delta z y is constant, exponent xy is constant. Okay, that's why when you delta z, okay, y z exponent xy, you get minus y exponent xy. Okay, this is component J. Okay, component K, delta x. Okay, when you delta x, okay, x and y are constant. Okay, so this okay, when you delta x, okay, delta x, y is constant, z is constant, so this is constant, but if you have the x here. So, okay, for delta x, x exponent xy, you have to use the product rule. Okay, the product rule where you have z is constant, so you may factor out the z, and then okay, when z is constant, you factor out the z. Delta x, x exponent xy, you apply the product rule. You have this is uv where you dd, okay, you ddx uv, you have u v prime where the u is the x. Okay, your v prime is the delta x exponent xy, you have y exponent xy. Okay, and then plus v, this is x, this is u v prime plus v, and then your delta x, which is u prime, is 1. Yeah. And then delta x negative 4y, you have 0. Then the second term here, you delta y 3x squared 0. Delta y, y, z exponent xy, also you have to use a product rule. Because when you delta y is only z constant, y exponent xy, you have to apply the product rule where you this one minus, okay, where delta y 3x squared 0, and then when you delta y, z here is constant, I factor out z, so minus z, and then delta y, y exponent xy, you have, okay, xy exponent xy, because you have q which is y, and then delta y exponent xy, you have x, that's why xy exponent xy, and then okay, you have this is uv prime plus v u prime, which is plus exponent xy. Okay, this one at component k. If you cannot one line, okay, then you okay, for delta x, x, z exponent xy, you do it okay, separately. But here I got limited space. Then you prove it, okay. So component I exactly you have component I, x exponent xy minus x exponent xy, okay, you get 0i. Component j also 0. Okay, component k, you see, okay, basically positive minus this one negative, also 0. That's why we get 0 vector. Okay, and then you have to write down, since the curve of f is okay, 0, okay, therefore f is conservative. Okay, but you have to show, okay, make sure you show, okay, that if you don't write this one, okay, you have to show this step, otherwise you will lose up, okay, the methods here. Okay, any question, okay, for the finding the curve of f? Basically, you must, okay, here is not only the product It's not only the cross product, but also you must also master your differentiation skill, mean the partial derivative skill as that you learned in chapter 1. Any questions here?
Okey,
Doktor, kalau statement tu kalau tak mention dalam jawapan tu bilang apa tak?
The last statement.
Dalam statement.
Yeah, because they ask you to show that's why you need to conclude that one. Yeah, you must state this one. Otherwise, look like you're not maybe losing 1 mark here. So this is only part A. Okay, after you show F is conservative, because they ask you to show, that's why you have to show the step. Show the step. Okay, here each component you get 0 vector, and you have to make the conclusion because curl of F you get 0. Therefore, F is conservative. Then you complete question A. And then part B, if F is conservative, we have learned we have 2 ways to find the line integral. Okay, one of it is using potential function phi, another one using the simplest path. But I use the simplest path here. You have to find a parametric equation. The easiest one is a straight line, but in 3D straight line. And then your F is very complicated. So for this case, it will be easier to use potential functions. Because the simplest path in here is not as simple. Unless it's 2D and unless it's at the x-axis, then you let y 0. Or on the y-axis, you let x equal to 0. That one will be simple, easy. Otherwise, normally potential function will be the easiest one. Okay, but since the question asks you to use a potential function phi, then you use a potential function phi. So we go to the question B. This is question B. If this is the F, and since F is conservative, okay, then F equal to del phi. So F, I put it into this notation for vector, which is 3x squared plus yz exponent xy at component I. Component j is xz exponent xy minus 4y. Component k is exponent xy minus 6 exponent 2z. Okay. Del is actually differential operator. Okay. Del x I plus del y j plus del z k. If f is 3 dimension, then del is 3 dimension. If f 2 dimension, then your del is 2 dimension. Phi is a scalar function. That's why you have a vector multiplied with a scalar. The result is vector, where we have del phi del x I, and then del phi del y j plus del phi del z k. This is vector times scalar. You get result still vector. Then you equal to f. Let it equal to del phi. So del phi del x, and then del phi del y j plus del phi del z k. And then you equal component by component. When you equal component I, you take component I. You have del phi del x equal to 3x squared plus yz exponent xy. And then to get the phi, you can integrate respect to x at both hand side. Because when you integrate del x and dx will cancel each other, then you get phi. So that's why you can get phi by integrate the component I respect to x. When you do integration respect to x here, respect to x, where y and z are constant. Y and z are constant. Asana, you off the mic.
Sorry.
Okay, so integrate 3x squared plus yz exponent xy dx, where y and z are constant. So you integrate 3x squared respect to x, you will have, okay, this is the first. We have 3x cubed divided by 3, so simplify, cancel 3 and 3, you got x cubed. Okay, and we integrate respect to x, y and z are constant. So you have here just yz, and then integrate exponent xy, you have exponent xy divided by x. Okay. The integral constant here is exactly when you integrate respect to x, so it will be y and z, the other two variables. Plus constant of y, z. This is first equation. First here, yz constant, you factor out, integrate exponent xy respect to x, oh sorry, this is wrong, divide by y. First, yz you okay, factor out, integrate exponent xy respect to x, so y is constant, that's why I get exponent xy divided by y. So P you have x cubed plus z exponent xy plus function of yz. This is first equation. And then from component j, okay, it takes a, compare the component j del phi del y equal to xz exponent xy minus 4y. So similarly, you can integrate, this is del y, so you integrate dy. So del y dy cancel, you get phi. So the right hand side also you integrate respect to y. So you get phi here. Okay, when you integrate respect to y, x and z are constant. So this is xz, you integrate exponent xy dy. So integrate negative 4y, you have negative 2y squared. Integrate respect to y, x and z are constant. So integrate exponent xy respect to y, you have exponent xy divided by x. Then you simplify, you get this is z exponent xy minus 2y squared plus 3xz. This is a second equation. And then you compare the component k. Component k, you get del phi del z. Okay, del phi del z equal to this one. exponent xy.
Y minus 6e exponent 2z.
Minus 6.
6 exponent 2z.
So here you can integrate both hand side respect to z. You get p here. So when you integrate respect to z, x and y are constant. That's why you have constant type z. So exponent xy get multiplied with z. So integrate negative 6 exponent 2z, you get negative 6 exponent 2z divided by 2. So plus this is. When integrate respect to z, x and y constant. So simplify it. Z exponent xy minus 3 exponent 2z plus h xy. Okay, the easiest way to combine the p is actually the easiest one. The p x y z function of x y z. You may start from your equation 1. Start from equation 1. X cubed plus z exponent xy. Then copy that. X cubed plus z exponent xy. Okay, you copy, take the term from equation 1. You have x cubed plus z exponent xy.
Betul.
Then you take out this term. Okay, and then you go to, from equation 1, you move to equation 2. Okay, the function of fyz is actually, this one we go with. Okay, you have x, so it's not this one. So this one is xyz. This is only y, this is xz. So okay, from equation 1, you take these two terms, function of y and z. You couldn't get it in equation 2. You have this one, negative 2y squared. This is a new term, then you take this one. Negative 2y squared. So you plus negative 2y squared. Okay, and then you move to equation 3. Okay, this term have already, okay, so don't take it anymore. This is a new term. Then you plus k. This is the easiest way to get the p. You see it one more time. You take from here, x cubed plus z exponent xy. Function of y and z, you want y and z. You don't have. So don't have. This is y, okay, y only. Go to equation 3 also. Don't have y and z. That's why it's actually plus k. Or okay, when you go to equation 2, this term new you take out here. This one, okay, and then new term is this one. Okay, this one. This one have already, don't take. So this is a new term, and lastly plus k. So this is the potential function phi. Any questions here? If you don't put k, I put any symbol. Let's say c also can. So any question to get the potential function phi here?
No.
Okay, so again, you must getting a potential function phi. You must know how to do your partial integrations here. When integrate respect to x, y, z constant. Integrate respect to y, x and z constant. Integrate respect to z, x and y constant. Then you combine, but don't add up. Okay, combine like you do the union of set. It takes the new element only. Okay, new. This one have already, don't take it anymore. Like you do union of set. Don't add up. You add up this term 1 time, 2 times, and then 3 times. Then the answer, you have 3 z exponent xy, which is wrong. So it's always take the new terms only. Okay, after we find the potential function, we can go to the question, part C here. Evaluate the work done by the force field F on the particle that move from this point to this point. So your line integral F dot dr along the curve C is equal to evaluate your potential function phi x, y, z. Okay, lower limit is a starting point, which is -2, 2, 0. Upper limit is the ending point 1, 0, -1. Okay, then put up your potential function. You have x cubed plus z exponent xy minus 2 y squared minus 3 exponent 2z plus k. From -2, 2, 0 to 1, 0, -1. Okay. So you may evaluate it by plug in the your upper limit deducts the lower limit. You to input this function to your calculator. XY calculator, you have A, B, C, D, E, F, X, Y, but you don't have the Z. Z, let's say I use M. Let's do minus 3 exponent 2. The Z, I use a variable M. I key in the functions x cubed, the Z in calculator, you don't have variable Z, I use M. Exponent xy minus 2y squared minus 3 exponent 2z. K only because cancel each other. Okay, and then I calculate. Okay, now I want to evaluate the upper limit. X is 1. Z, M is Z, Z is -1. Y is 0. The answer here. I have this answer. Save this one. Set into variable A. Okay, I save the answer here into variable A. This is the upper limit. We call back the function. Calculate. Okay. Now x is -2. M is Z is 0. okay, and y is actually 2, negative 19. So I can so I call a back a, upper limit deduct lower limit, right, minus the b. So the answer is 18.59. If you round it to 2 decimal places, 18.6. This is using a calculator. If 2 decimal, okay, up to 2 decimal place, you get this is 18.860. Okay, any questions here? This one, I just show you how to you calculate, because you calculate this function, okay, the potential function you calculate for 2 times, right? So I just key in, okay, this function, and z I use variable m, and then I calculate. Okay, this is the last calculation. X is negative 2. You want to see z is 0, y is 2, and get the answer is negative 19. Okay, if you don't want to save, you can also put out when you write down. If you don't want to save, if you write down, you will have the what we call rounding error. And then this is I calculate negative 19 minus negative 19 minus negative 19, and then I calculate again. This is for upper limit, x is 1. M now is negative 1, y is 0. Negative, okay, if you round it, this is, you have rounding error. Okay, so that's why if I save it, I will take out all the decimal place. So mean this answer minus, okay, negative 19, so it's actually your plus 19. That's why the answer is 18.594. We use 3 decimal place. This answer is negative 0.404060. It's just now, okay, I just want to save this answer in, let's say, I want to save with just STO into variable A. Just key in this one, you see, answers keep to A. And then when you want to call back A, you press alpha A. Then you will call back the answer A. Okay, just now the negative 19 I saved in variable B. So alpha B, call back negative 19. Okay, so you use, press A minus B. I saved the wrong, because I saved the wrong A already. Okay, A I saved wrongly, and you can this one. No, correct. So A minus okay, so how to use how to put it to function and you calculate it repeatedly will be useful, especially for your engineering mathematics for numerical method. In picking of the variable, put it to function and continue calculate. This technique will be useful when you learn the engineering mathematics. Okay, but if you don't like this way, you want to calculate manual, also can, up to you. Okay, so this is the conservative vector field. First question. So question 2, I think also same. Okay, all the pattern are the same. Move to one question in Green's theorem. Okay, last night we have seen the question 1, 2, 3, 4. Okay, I think almost the same function. We look a little bit different questions. Let's say question 5. Green's theorem, question 5. This is Green's theorem. Okay, evaluate the line integral. Okay, this one is suppose we have the arrow in something like this, but in the equation we cannot see the arrow there. So mean the line integral, which is a closed, why? Okay, this one is mean the closed curve anti-clockwise. So this is a closed curve anti-clockwise direction. Then we can use the Green's theorem, and where the curve C is the boundary of the region enclosed between y equal to x squared and x equal to y squared. So we plot out the region R. This is here, y equal x squared in the first, okay, I just draw the first quadrant. And then x equal y squared. The black color is x equal y squared. Also, I just draw, okay, at the first quadrant only. If you want complete, it will be like this. So the intersection of the y equal x squared and x equal y squared is at the first quadrant, where the C is the boundary of the region, enclosed by the y equal x squared. To use the Green's theorem, normally we'll fix the direction anti-clockwise. Here. So the intersection is of course when from the graph can see is at the origin 0, 0. Okay, and then y equal to x squared and x equal to y squared is intersect at 1. This is common. In this point is actually here 1, 1. Because when you solve y equal to x squared and x equal y squared, we plug in here. So y will be x squared, so this will be y power 4. So y power 4 minus y equals 0. So y cubed minus 1 equals 0. So it's either y equal to 0 or y cubed equal to 1 because y is 1. So when y is 1, x squared you have 1 and negative 1. So this is 1. So this is a region R. They actually traverse from the point 0, 0 to 1, 1 along the curve y equal to x squared. Okay, y equal to x squared will be the first curve C1, and then okay, from 1, 1 up to 0, 0 along the curve C2, which is described by x equal y squared. Okay, so okay, this is just sketching the region R. Okay, and then since the curve is closed and anti-clockwise form region R, then you can evaluate this line integral using Green's theorem. If you not apply Green's theorem, then you need to apply do the line integral 2 times where along the curve C1. Okay, do it 1 time along curve C2, do it 1 time total 2 times. So you have two times of job. So if you use a Green's theorem, because the curve is anti-clockwise and closed, once it's formed region R, then if you apply Green's theorem, will be faster. So now we apply the Green's theorem. Okay, so for Green's theorem, instead of evaluate line integral, you evaluate the double integral, where this is actually your del x, coefficient of dy, which is x squared y cubed plus 2y minus del y, coefficient of dx, which is x squared minus 3xy, okay, and then dA. So you evaluate the del x squared y cubed plus 2y minus del y x squared minus 3xy dy. And then lastly, you evaluate become the problem of double integral. So first of all, okay, we evaluate here. When you del x, y is constant. That's why del x squared y cubed, you will have 2x y cubed. Del x 2y will be 0. Then the second term, del y x squared will be 0. Del y negative 3xy, you have negative 3x. So with negative outside, so total is plus 3x. And A. So up to here, so far, any questions here?
No.
Okay, so means you actually use back your partial integration, the partial derivative, and then in delta x delta y is in chapter 1, and then you do the double integral will be your chapter 2. Okay, so we already draw the region. This is in this region. So will you use Cartesian coordinate or polar coordinate? Yes, Cartesian coordinate. So we apply the Cartesian coordinate. So in this case, which one will be easier to use? dy dx or dx dy? Which one? You choose dy dx or dx dy?
Tergantung pada kita start mana dia punya nombor ni betul.
Which one easier?
Dua dia.
dy dx will be easier because you have x also can. You want this one x already title. This one you have to change x in terms of the title. then if you use dy dx, then it forms a vertical bar here. The lower curve will be the lower limit y equal x squared. Upper curve, this is x as a title. You have to make, if you use dy dx, you have to make y as a title. Y will be equal to positive sub x. So actually, both also can. If you use dx dy, the second term here, you have to make x as a title. Okay, here I fix the dy dx. Okay, therefore, so x from 0 to 1, y from x squared until sub x. X, y plus 3x. This is dy dx. Okay, low limit y equal x squared. Upper limit of y. You want to integrate respect to y, you have to make y as a title. That's why y is positive x. Because quadrant 1 y is positive. The fourth quadrant, this one is actually y equal negative sub x. Okay, and then you sum vertical bar from left, which is x equals 0 until the right point, which is x equal 1. So now become the double integral. And then we just evaluate it. Okay, integrate respect to y where the x is constant. So you have 2xy power 4 divided by 4. Okay. 3x is constant, so integrate constant respect to y, you have 3xy. Okay, substitute from x squared until sub x and dx. Okay, and then so you get this one becomes x. Okay, integrate respect to x, plug in into y. Simplify 2 and 4 become divided by 2. So sub x power 4. Okay, we'll have x squared. Sub x power 4 plus 3x sub x. Minus substitution of lower limit, which is x, which is y equal to x squared. Same here, and then x squared power 4 by 2, 3x x squared. So yeah, lower limit. Lastly, integrate respect to x. So sub x power 4, you have x squared times x, so you have x cubed over 2. So this is 3x power 1 is power half, so power 3 over 2 minus, okay, we have here x, this is power 4, 6 plus 1 power 7 divided by 2. Open the minus here. So we minus, this is 3x cubed. Okay, and then lastly, integrate respect to x. Okay. So we have x power 4. 4 times 2 is 8 plus 3x power 5 over 2 divide by 5 over 2, so minus x power 8, so 8 times 2, 16, 3x power 4 divided by 4, evaluate it from 0 to 1. This one divide by 5 over 2, so you reverse it, it becomes 3 times 2 over 5. Okay, and then plug in x is 1, we have The answer is 1. So minus 1 over 16 minus 3 over 4. Okay, we quickly use a calculator. So 1 divided by 8. 8 plus, this is 6 over 5. And then minus 1 over 16 minus 3 over 4. So 41 over 18. Zero point 5125. Check whether the answer correct. Second, 525. The answer 525. I think mistake. Whether I got the answer wrongly. First of all, check this one. So xy cubed plus 3x correct. And then integrate here. It's equal to 6x. To integrate respect to y, you get a xy power 2 plus 3xy. This one you get xy power 4 divided by 2 plus 3xy. This is correct. Okay, plug in the upper limit. Checking up to here correct, checking whether your upper limit. Okay, x times y power 4. So you have this one. So x power 4 is x squared, so x cubed over 2. Here is 3x cubed. Okay, we simplify this one. 2, 0 to 1. Okay, half minus 3. This one. 3x power 3 over 2. Okay, this is x cubed. Okay, this term and this term combined. Checking. So 3x power 3 over 2. This term and this term, okay, this term combined at negative half minus 6 over 2, so minus 5 over 2 x cubed. Okay, this term. Here, mistake is here. Okay, x squared power 4, okay, 2 times 4 is 8. So, okay, this one more. Okay, the mistake is here. This is 9. This term. Okay, because, okay, and then, so mean this one correct. Here, x power 4 over 8. Here, x power 10 over 18. So this is x power 10 okay, over 20. Okay, this term, x k power 1 times x k squared power 4. This is x power 8, and then okay, 8 add up 1, so x power 9 over 2. Integrate this term is x power 10. In this one, x power 9 over 2. This is 9 dx. So this is x power 10. Okay, so divide by 2, divide by 10. So this is 20. That's why the mistake is here. This is 1 over 8. This is 2 over. This is 1 over 20 here. So 1 over 8 is 3 times 2 over 5 is 6 over 5. So minus okay, 1 over 20. So is 21 over 40. 21 over 40, which is 0.525. So this is the correct answer. Okay, 21 over 40 or 0.525. In the mistake just now here, this term. So any questions here? This is a Green's theorem.
No.
No, maybe. Let's see. Less is the same thing. At the question 10, this one we solve number 5. Number 5, this one done. This is using the polar. This one like the actually the yesterday okay, the first example, the lecture notes. This one okay, enclosed by y equal x squared and y equal to x. So let's say question 10. Use Green's theorem to evaluate the line integral y cubed dx plus x cubed plus 3xy squared y, where the c consists of the line c1. C1 is from 0, 0 to 2, 0. C2 from 2, 0 to 3, 1. C3 from 3, 1 to 0, 0. Once you have to sketch the point that the C1, C2, C3. So sketching in this first quadrant. So this is the x, this is the y. It's 0, 0 here, to 2, 0 here. This is C1. from 0, 0 to 2, 0. C2 is from 2, 0 to 3, 1. C1, C2, 2, 0, 3, 1. C1, C2. So this is a C2. C3 from 3, 1 to 0, 0. So C3. So the region R is bounded by C1, C2, C3. This question is C1 along the x-axis, C2 to 0 to 3, 1, C3 3, 1 to 0, 0. Thinking the challenging part is how to obtain the equations here. Okay, this question, the challenging part, how do you obtain the straight line equation there? And how to get the equation for C2 and C3? Okay, how to get the curve for C2? Because later on we want to do double integral. We want to do double integral. Okay. And then is it using dy dx or dx dy? This one is bounded by left, right, or top, bottom. Left, right. Okay, left, right curve. Because if you use top, bottom, you have to divide into two regions. If you use dy dx, then you have two different regions. Because let's say the left region, bottom is at x-axis, top is on the curve C1. Okay, after the point when x is 2, bottom region is bottom curve is C2, top curve is C3. So in this, if you use dy dx, you have to divide the region to two regions. But if you use dx dy, in this case, is always consistent. Your left curve is C3, the right curve is, because you see your horizontal bar is always consistent. Left curve is C3, right curve is C2. Okay, so the problem now, how to get the equation for curve C2 and C3. So using the straight line equation, you have what? You see, if y equal m, here this one you have y equal to mx plus c, it will be suitable, I think, for C3. Curve C3. Using the y equal mx plus c will be suitable for curve C3 because we have the y-intercept. Okay, in here y-intercept is 0 because C3 touch up to here 0, 0. Okay, and you need to find the slope. Okay, for C3 exactly. To find the m, it takes 1 minus 0. y2 minus y1, and then x2, which is 3 minus 0. So c is 0. That's why y you have x over 3. Okay, or x equal 3, 1. For curve C3, we have the equation x equal 3, 1. Okay, C2. C2, we have another equation. how you get the C2? Another linear, another straight line equation for the C2. We have to get equation for curve C2 here. We have another form, let's say y minus k equal mx minus h for curve C2, where the hk is any point that passing through by this curve. You can choose 2, 0, I can choose 3, 1. Let's say C2, I choose hk, I choose 2, 0. And this is another straight line equation, y minus k equal mx plus h, where the hk are any point that passing through by this curve C2. So in this case, I choose 2, 0. So you have y minus 0. Okay, m is a slope. Okay, you have 1. Then the y, 1 minus 0, divide 3 minus 2. Okay, and then x minus the h is here is 2. So y 3 minus 2 is 1, so you have actually x minus 2. Okay, the C2, the linear, the straight line equation that you obtain is actually y equal x minus 2. Okay, and we want to make x as a title, so x is actually y plus 2. So this is, recall back the straight line equation that you have learned in your secondary school. So okay, here we are going to use the dx dy in form horizontal bar. Okay, and the horizontal bar is actually you sum from the bottom, which is y0, until the top, which is y equal 1. Okay, but before that, you have to apply the Green's theorem. Okay, so the Green's theorem, double integral across region R, where you del x coefficient for y, which is x cubed plus 3x y squared minus you del y coefficient for dx, which is y cubed dA. So del x cubed, you have 3x squared. Del x 3xy squared, you have 3y squared. Del y cubed, so you have minus 3y squared dA. And then you simplify, you get 3x squared dA. Across the region R. The region R in this case will be easier. We solve it using dx dy. I mean we find the area by forming horizontal bar. So the left curve is actually C3, which is x equal 3y. Left curve will be the lower limit, right curve will be the upper limit. So mean the lower limit is from 3y up to upper limit y x equal y plus 2. Therefore, limit of y 0 up to 1. 3y is a lower limit. Upper limit is y plus 2. X equal y plus 2. 3x squared dx dy. So factor out 3. Oh, no need. Let's cancel each other. So integrate 3x squared. Integrate 3x squared respect to x, the x cubed plus 3 and over 3 cancel each other. So plug in the limit from 3y up to y plus 2. Y plus 2 cube minus 3y cube d1. We're going to y plus 2 cube minus this will be 27y cube. And solve it quickly using your scientific calculator. Cos k in calculator, you have to change y to x. Zero to 1. So x bracket y plus 2 in calculator x plus 2 cube minus 27 x cube dx from 0 to 1. Okay, answer 19 over 2. So, check the answer. 27 over 2. Check my mistake. Calculator 19 over 2. Do it manually. One plus 2 power 4 divided by 4 minus 27 y power 4 divided by 4 0 to 1 1 over 2 3 power 4 divided by 4 minus 27 divided by 4 3 power 4 divided by 4 8 minus 27 divided by 27 over 2. expand it, see. This one you see this is 65 over 4. Okay, expand y plus 2 cube. I'm going to check why the answer different. This one using the integral I let q of this one. Check this. Let u is actually y plus 2. So du is actually dy. So you integrate y plus 2 cube dy is a u cube du. So that u power 4 divided by 4. So it's y plus 2 power 4 divided by 4. Plug in y is 1, 1 plus 2 is 3, 3 power 4 is 81. This one is 65 over 4. So this one minus 57 divided by 4. This integral. Okay, I'm going to check the first integral. If I expand it, oh, I know what's a mistake here. This result is correct, but missing the correct answer is by the calculator. This one. Okay, using the calculator, 19 over 2 is the correct answer. This one, 19 over 2. Okay, and using the manual one, okay, the mistake is when I forgot to plug in 0 in the first term. That's why the answer provided in the worksheet I give this one is actually I forgot to plug in the substitution of y equal 0. Is integral correct? Because I have to deduct with minus when y0, plug in y0 here, we have a 2 power 4 divided by 4. Okay, second term y0 is 0. Okay, miss out this term. That's why we have a 3 power 4 divided by 4. Okay, and then minus 27 divided by 4 minus this is 2 power 2 power 4 divided by 4. 19 over 2. And the answer for y by me here is actually this answer is wrong. 19 over 2. Because I forgot to deduct the substitution of y equal 0. So this one, the question 10, this is question 10. Question 10, the Green's theorem, because you have a curve C1, C2, C3, if you're not using Green's theorem, you have to do it, curve C1, C2, C3 3 times of the works. Since C1, C2 travels in anti-clockwise and it forms anti-clockwise and it close, it forms region R. Region R in this case is actually consistent. It's bounded by left curve, which is C3, right curve, which is C2. That's why we use dx dy. Okay, the challenging is here you have to recall back how to get the straight line equation from the knowledge that you learned in secondary school. Curve C3, because we have the y, C is actually the y-intercept, so you use y equal mx plus c. And then the m is a slope. Slope you take any, in the m, you take any 2 point, y2 minus y1 divided by x2 minus x1. So it finds a m here. And then since the region R is consistently bounded by left curve, right curve. We use dx dy. We have to make x as a title, so x equals 3y. Left curve is lower limit of your x. And then C2, the right curve is the upper limit of your x. Okay, x here, you don't have the y from the figure. We cannot see, okay, where's the y-intercept unless you extend it. Okay, or we can use another version of straight line equation, which is y minus k equal m bracket x minus k, where hk is any point passes through by the curve C2. In this case, I choose 2, 0, because 0 easy to calculate. So, okay, hk is an xy point passing through by the C2. So, k is here 0. Choose this point because it got 0 easy to calculate. So, m again I take y2 1. So, 1 minus 0. x2 is 3 minus 0. Oh, sorry. 1 minus 0, 3 minus 2. So, m is 1. So you have y equal to x minus 2. Because we want to use dx dy, make x as a title. So this one is the upper limit. This is the lower limit. Lower limit. Okay, and then this part is a Green's theorem. Because okay, you have the C anticlockwise, and then form the region closed, and it forms a region R. So it applies Green's theorem. Is del del x coefficient of dy minus del del y coefficient of dx. So you simplify, you have 3x squared dA. In this case, we use dx dy. Okay, lower limit of x is the left curve, upper limit is the right curve. And then lower limit of y is the bottom. Okay, the bottom point, this is the top point. So 0 to 1. And you just integrate respect to x here. Okay, and then plug in the limit. Okay, here, y plus 2 cube minus up to here, like minus 27y cube. Okay, you may directly using calculator, you get the 19 over 2. Okay, and if you evaluate manually, this one no need to expand here. You expand more term, then if you want to expand also can, but okay, more work, so you have to expand. You have total 4 terms, so one more term, 5th term. Okay, the easiest is directly using your calculator in this step. Okay, or okay, this is using substitution technique. Let u is y plus 2, du is dy, so integrate y plus 2 cube dy. We become integrate u cube du. So you have u power 4 over 4, where the u is y plus 2, so power 4 over 4. So integrate 27y cube is 27y power 4 divided by 4 from 0 to 1. Okay, the mistake in the answer is actually forgot to put in the calculation of 0. Because when you plug in 0, we have here 2 power 4 over 4. So that's why the correct answer is what provided in the calculator. So do you have any questions? We have solved one conservative field, and then 2 questions for the Green's theorem. If you have no question, you can go to the author. You may go to author and then the assessment tab, looking at your quiz 3. Submit it by 6 p.m. Good. And then who else haven't scanned the attendance?